Good day, good morning, good afternoon, good evening. This is all about the windings inside a three-phase motor. Based on our previous video about the two-pole configuration or four-pole configuration or two-speed three-phase motor. And say for example, the basic three-phase motor 6 leads out star or delta configuration or connection similar to this one. We will have 6 terminals out and can be possibly connected in star or delta. The section here is a stator winding, a cross section of a stator winding. Shall we say one part or one area of a stator winding. 24 slots. Windings are inserted here. Windings are inserted in these slots, semi-closed slots. When we say coil span, that refers to the distance of the first slot to the next slot where we are going to place the coil. We have 4 coil pits here or coil span 1 to 8, 1 to 10, 1 to 12. So we will be having 4 coils per group, 1 to 6, 1 coil, 1 to 8, 1 coil, 1 to 10, 1 coil, 1 to 12, 1 coil. Since in a two-pole configuration, let's say the two-pole pattern, two-pole configuration is similar to this one. If this is our terminal 1, this is the first phase, terminal 1 or T1, and that will be 4. Phase A, phase B, phase C. So this is the pattern how to make a two-pole connection. If we are going outside this circular stator, we will term them as North Pole, and if it is going inside, it is South Pole. You can have positive, negative, or A and B, 1 or 2. It depends on your preference. You can have the opposite way, south or north. We will bring this south to the nearest north, the first one, to establish another north. There will be no slots apart between them to cancel out and become one north. And this will also become a south polarity. And this will be terminal number 4. So we have now one north and one south forming a two-pole configuration. You cannot say you have 4 norths there. I mean 2 norths and 2 souths. Because in reality, magnetic fields will cancel out. The resultant will become one strong magnetic north and one strong magnetic south. So we're going to place that one here using this data. 1 to 6 is this one, followed by the next one. So that is understandable that this is 8. 1, 2, 3, 4, 5, 6, 7, 8. There are 2 slots being generated there. Next one is 1 to 10. Then last one 1 to 12. Now this is now one group. That is now the one group. Let's say one group, one pole, one set of winding. The other set is opposite to this one. Since a two-pole configuration has 2 groups, that should be the minimum, the 2 groups. Because you need a 4-pole polarity, I mean North Pole polarity and South Pole polarity. So we will make the other group opposite to this one, that is 180 degrees, to complete one phase. This is 12. So the last winding is this one. There are 4 of them. So we have 1, 2, 3, 4. So this is the smallest one. 1, 2, 3, 4, 5, 6. This one. So count 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So here is the smallest one. 1 to 6. We will check if they are 180 degrees. Each coil consists of turns of electromagnetic wires, insulated electromagnetic wire, or electromagnet wires. It can be a hermetic type, or heavy, or the single insulated. Depends on the manufacturer. Class A, Class B, or usually the hermetically or the other high-end magnetic wires are for compressor type motors or severely for severe application class motor. We have here terminal 1. Okay. There will be 8 coils in this phase. So in reality, one group of coil are formed using this one. Let's say we have one coil formed for 1 to 6. Let's say 100 turns, one form. Then the next form, let's say another 100 turns, next another one, until you have the fourth one. So this is 1 to 6, 1 to 8, 1 to 10, then 1 to 12. You have the output here of the first group. 1, the output, so this one is the output. Slot number 9. If we're going to follow this pattern, this connection is inside, they're connected inside. We will go, and this will be north. These are all north here, north, 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 all south here, north, south, series. It will be connected that way in series. So this one, and they are continuously coiled, making 1, 2, 3, 4 types of coil forms. 1, 2, 12. And the output is this one. It should go to this area, either this big pitch or this one, doesn't matter. We will do the principle of big to small coil span, but they will still make a polarity even if you go to the big coil span. So this will become north, and this will become south. So again, similar to this one, another group of coils. Then, if you input this side, same with this one, input, output should be here. You input to the small coil span, the output is on the big coil span, because it will go directly this one. Continuous forming of coil, then this one. By the way, that is the internal connection between two groups. This one. This one. Going to the next coil group. So we have the output here. At if you enter at the small coil span, so the output is this one. So this will be one phase completing this circuit. Now, what is the characteristics of connection of the first phase? Is the same with phase B and C because they have the same characteristics. In a three-phase motor, it should be balance impedance, balance noise, balance current. They are always assumed balanced. Although they are not balanced when they are finished product because there are differences of 0.00 something, but assume them when you make them and when you connect them, they are in balance because that is the characteristics of a three-phase winding. Next, how to make the first and second phase. You disregard the polarity of the first phase. Then this is north. This is all north here, so they will become one north based on this one. And they are all south here. They will become one south. Okay, remember in each when windings are energized, they have independent polarity. Let's say we are energizing the T1 and T4. It will make its own polarity. And next, the second phase, and next, the third phase. This is phase A. When you're going to read phase A, you have to read this one independently with the phase B and C. So disregard all the polarity of phase A and make another polarity of phase B. So we can plot the next phase, the terminal 2 and 5, by using the 120 degrees distance. So if we have 24 slots divided by 3, we have 8 slots apart between phase A, phase B, phase C terminal. 120 degrees. So let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the slot number, the terminal 2 is somewhere in slot number 8. So we will do this way. From this first terminal T1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So terminal of phase 2 is here. This will be 1 to 6. 1 to 8. 1 to 10 and 1 to 12. Okay, do the other one. Opposite similar to this one. 1, 2, 3, 4. Have distance of 1, 2, 3, 4. Same to this one. 1, 2, 3, 4. This is the smallest bits. 1, 1, 2, 3, 4, 5, 6. So it should be here. Okay, no slots between them to make a two-pole connection. So how to make the distance 120 degrees? 8 slots apart. So small one. So it should be here. T2. Count the distance between 1 and 4 and follow to the second phase. So if we start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You start here, that is 9 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it is clear that is 1 and 10. So we count this one also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the output of phase 2. And this is terminal number 5. Okay, we go terminal 3. Terminal 3 again is 8 slots apart following this one. Or if you start here, that is 9 slots. You start here, that is 8 slots, so we will use this one. 1, 2, 3, 4, 5, 6, 7, 8. So, coming here, clockwise, 1, 2, 3, 4, 5, 6, 7, 8. So this is the smallest bits of phase C. So 3 and 3 and 6. Again, 1, 2, 3, 4, 5, 6. So this one. You can also see that all the slots should be filled with 2 coils per slot, and there should be no vacant or 1 coil in each slot. So again, follow the 180 degrees arrangement based on phase A and B. So we have 1, 2, 1, 2, 3, 4. This is the smallest bits. Block 1, 2, 3, 4. So no slots between them. 2, 3, 4, 5, 6. So this is only one coil here. So we have 1 to 6, 1 to 8, 1 to 10, and 1 to 2. All the slots should be filled with 2 coils per slot. No vacant there. That is filled with 2 coils per slot, and it should be balanced 2 coils per slot. You have 8 coils per group. 8 times 3, that is 24 coils per, 24 coils total. So if we are going to place terminal 3, 1, 2, 3, 4, 5, 6, 7, 8, where is that? This one is terminal 3, and you count again 10 slots apart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the output of terminal 3, which is terminal 6. If you count the distance between 4, 5, 6, that is also 120 degrees distance. 4 and 6, 1, 2. It should be 8 slots after this terminal, or 9 slots from the original terminal. Say 1, 2, 3, 4, 5, 6, 7, 8. Okay, here 1, 2, 3, 4, 5, 6, 7, 8. So this is T3. 4, 5, 6. I mean 1, 2, 3, 4, 5, 6, 7, 8. Okay, T5. So this is the two-pole configuration. I still the a bit complex dealing with the windings. Just follow this pattern. Next, we will do the four-pole connection and how to combine them in one motor. So, what to take note here? The pattern, making two poles, north, south, north, south. They will cancel out as one north, will cancel as one south. So you have two-pole polarity. How to form the one group? That is one coil, another coil, another coil, another coil. This is one group or one pole, and one pole is equivalent to one group, this one, and they are located 180 degrees. What is the characteristics of the first phase? The same with the second phase and the third phase. The distances of the terminals are equally distributed according to the number of slots. So you have 8, 24 divided by 3, it's slots apart. You have 6 leads out, you can connect the motor in ordinary Y and delta. We term this one concentric because that is increasing. The other one is lap winding. When you say lap winding, there is only one coil pitch. and they are overlapping with each other. This is 1 to 6. This is 2 to 7. The count there is still 1 to 6. One pitch only, one coil span only. We call that one as lap winding. This one is concentric. For the next winding, we will combine them with 4-pole and 2-pole configuration in one motor.